And we've got a very special guest today, Professor Patrick Stewart from University of Arkansas, Political Science Department, and a foremost expert in nonverbal and particularly facial um, detection and movement. And he's going to lecture us today on what we can learn and how we can use the video library in facial analysis.
Okay, well, thank you very much. It's really an honor to be brought in on this, to go ahead and talk with y'all. And I have to say that while I am going to talk to a certain extent about facial displays, I'm going to broaden it out a bit to look at nonverbals more generally. But I think more important is that we have some partners that have come in that I am truly excited about being a part of this. So what I'm going to do is share the screen and start up the PowerPoint. So I'm a political ethologist, and that means for me that behavior matters more than anything else. It certainly means more than words, because words are cheap, whereas actions are costly. They're costly physiologically, and they have evolutionary implications on down the road. So I teach the importance of narratives to my students. Certainly, words do matter in politics, but the actions that are alongside those words are exceptionally important. So that is what we want to focus on. And this is why C-SPAN is so incredible, and why I am so honored to be here today is because C-SPAN and the Center for C-SPAN Scholarship Engagement has been around since, I've heard, 1979 and 1986. Robert, I'm going to defer to you. What is the official starting time for y'all?
1987 for the archives, and the center in 2017.
Okay, excellent. So the thing is the way I consider this, it's a repository for democracy. And arguably one could say this is the digital age's Library of Congress. And if a picture is worth 1,000 words, then the moving pictures housed in the videos in the C-SPAN archives are worth immensely more. So obviously I wish I could be in West Lafayette in person. I've got some fond memories of breaking down there and being hosted there. But with this ongoing pandemic, we've all had to adapt, and we all have a very different world that we're dealing with. In some ways it's easier, but in some ways it's a little bit discombobulating. The Zooming that we're doing right now is obviously, I am right across from all of you. You're looking at me, and this is a very personal situation that we normally wouldn't do. And we also wouldn't have to worry about what's in the background. And so we end up doing things such as choosing and curating our backgrounds. In my case, I've got a daughter who's 6 years old, first grade, and she shares this space with me. So it's what we do. We're sharing spaces. And we know that our words and actions are under scrutiny because pretty much all the Zoom sessions are being taped. So we're living in an experiment, and we're fortunate in that most of us have jobs where we can Zoom from home. But there are things as we move forward from the vaccination I think is going to be important to consider, and that is nonverbals. How do we reintegrate ourselves with others, and how do we consider the political arena with the newfound knowledge by having contacts with others taken away from us? So that takes us to the next. Let's go ahead and make sure. This is the organization that I've got here, and I've got 4 elements that I'm focusing on. And it's highlighting important partners. So the first part of this is, it's going to be around 30 minutes. I'm going to talk about the social brain theory, how it relates to nonverbal behavior that is covered on C-SPAN. And the partner here that matters most of all is the C-SPAN archives, because we're able to look at political figures over a long period of time, and we're able to look at the evidence of how they act, not just the words, but how they act. And so I'm going to present some fundamentals of nonverbal behavior and social behavior. Secondly, I'm going to present a brief introduction to the facial action coding system. We'll be identifying and coding the major muscles. Essentially, we're going to be making faces at each other. I hope we can go ahead and show everyone else's faces so we can make the faces, because this is the starting point, understanding the muscular movements in the face. allows for us to break down what is going on and what is being signaled. And if you decide to move forward, I'm going to link you up with Erica Rosenberg. Erica Rosenberg has a legacy that goes back in research, teaching, and training that essentially, if you do the facial action coding system, you're 1 to 2 steps away from her in one sense or another. Now, from there, the final 2 segments are going to be looking at the new technologies that are coming out that are going to transform how we approach teaching and research. And I think this is the most exciting part for me, because we're bringing in partners from iMotions, which is Ashton Therian and Koivo, and from Noldus with Shannon Sanguinetti and Peter Chen, who are going to be presenting in response to my introduction as far as how I'm using technology in the classroom and how the research applications that I'm using can be essentially taken to the next level that we're moving towards. And I'm going to ask them to present their technology on its own terms so you can make the decision when you make comparisons. They won't be comparing with each other. They'll just be talking about their technologies. And from there, we're going to conclude quite briefly by bringing up some of the ethical questions that we are going to have to deal with as the new technologies become used much more so. So let's go ahead and start off with the social brain and brain size and sociality. Now, over the years, we're going back into evolutionary history, and the question is, why are humans how they are? Humans have extremely large brains, and we spend a lot of calories just keeping those brains going. The question is, why? How did it evolve? One of the arguments is that as our brain size grew, our social groups grew. And this leads us to the idea of Dunbar's number of about 150 people that we can develop friendships with. And these are the individuals that we will keep track of, that we will send birthday cards to, or it's those that in our social network on Facebook, if you're still on Facebook, that you keep track of and try to say hi to on a regular basis. But when we dig deeper, we see that there are concentric layers of connection that we have within our groups. Those people, the tight 5, those who are closest, are the ones that we spend most of our time with and we have most of our contacts with. And the next 15, which makes about 20 total, and of course there's a plus minus here, these are the ones that we do spend time with, but certainly not as much as those who we are closest to. And there's diminishing amounts of time until we get to about 150 or 500. And the research out there suggests that we've got probably good enough memory for about 1,500 faces. And I know that there's a lot of instructors and teachers and professors on board here. And that's one of the challenges that we face, is that oftentimes we'll see someone, we might remember the face, but we cannot recall where. It's because we have limited capacity. Now, of course, there are going to be those outliers. Bill Clinton is one of those who can tell you where he saw you for tens of thousands, if not more. But this helps us understand where we're coming from and how our sociality has evolved. Now, one of the strong inferences that can be made thanks to the social brain theory is that these contacts vary not just in the amount of contacts and the amount of time, but also qualitatively. So physically, there's going to be more time that is spent with individuals, and this is seen in proxemics. As we get closer to people, we have different sorts of relationships with them. And this, once again, leads us to the idea that this is important information. The nonverbal behavior that we engage in is exceptionally revealing, especially in those spaces in time between scripted actions, between when we're saying words. And so this leads us to the important slide for me, which is that of haptics, or touching behavior. Now, touching behavior, it's an intimacy focused. And I think one of the things that might have been strengthened through the pandemic is that we spend more time with those people who are close to us. And touch reduces stress, it increases attachment, and it's a way of communicating information of love, sympathy. On the other hand, it may be used to exert control, but you still have to let someone in close enough to touch you. And this leads us to our first example that C-SPAN helps us, well, basically explore to a greater extent, which is the idea of handshakes and hugs. Now, underneath, you'll see a link here if you want to do that. I've been fortunate enough to do public communication, more or less. I'm trying to teach the public by responding to current events, which is what C-SPAN does so exceptionally well, is it shows us how things are going politically, what is going on. So the first thing that I'd like to look at is that of the shaking of hands. Now, the haptics of handshaking plays a role in our evaluation of others. We can tell by how strong or weak the grip is, a little bit about the personality. How warm or cold the hand is, how dry or clammy the skin tells us about the health of an individual. And when we look at political figures, we know that they have developed handshaking skills over the years to communicate dominance or to communicate warmth. I teach a class when I'm in person and we go over the different handshakes. And one of the classic handshakes is the Bill Clinton handshake, where I'm going to do this, he'll shake a hand, then he'll clasp with the other hand and make you feel encompassed by him. And there's a certain warmth that's there that he communicates. Now, with other political figures, it might not be as subtle, and we can see some things that are going on with the handshaking. And we'll see a video in a few moments here, because I just want to go ahead and let it flow through. The next issue is that of hugs. Hugs provides information, especially those in the inner circle, based upon the proximity that you have with the other person. With our family, our close family, our children, the people who are our spouses or significant others, these hugs are oftentimes very close and involve the entire body touching. But as we move further away from someone in our connections, we might have a hand in between, you might have space in between the bodies, or you might even be controlling them physically. And so there are different things that might show up in different types of hugs. And so what I'd like to do now is just show you some video and have you make your own conclusions.
Mr. President, they're all saying what a great relationship we have. And they're actually correct. It's not fake news. Finally, it's not fake news. So it's a great honor to be here. But we do have a very special relationship. In fact, I'll get that piece of dinner. We have to make him perfect. He is perfect. So it is really great to be with you, and you are a special friend. Thank you. Thank you. Thank you very much, Mr. President.
Yep. Okay, so the next step, and I'm going to focus most of my efforts on facial display behavior, but this is the next stage. This is the next stage where we're looking at the 150 people that are in a group, in a social group, where we want to communicate to them our preferred action tendencies. And oftentimes this is for the purpose of survival, and it includes such things as anger, fear, disgust, sadness, and happiness more broadly. Now, each one of these has identifiable distinct signal properties that can be distinguished rather quickly and can be seen at a distance. We have the white patches of our eyes and our teeth that allow for us to communicate a smile up to about 100 meters. And interestingly, 100 meters is how far you can throw a stick or a rock at someone. So obviously, being able to approach someone or avoid someone becomes extremely important. Now, the thing that's fascinating, especially as you start looking at the finer details of the facial display behavior, is it becomes even more elaborated based upon the circumstances, but then it might also indicate individual personality traits and behavioral tendencies. In other words, every individual has their own nonverbal repertoire that they have developed. And this gives us information as we look at political figures over a long period of time. Now, this next slide that we're looking at, let's see if I can actually, there we go. We'll be looking at Brett Kavanaugh in his 45-minute, we're not going to watch the entire 45 minutes, it's only about a minute and a half, but he had a 45-minute hearing in front of the Senate Judiciary Committee, and it was dealing with the sexual assault issues that he was dealing with them. And during this time, he showed some very interesting display behavior. He had a left-sided lip corner tightener, which is it's connected with contempt. He had tongue shows, which is connected with distaste. And there was an awful lot of pressing of the tongue to the inside of the cheek during this time period, which is connected with potentially regret. It's not studied as much, where certainly contempt is studied an awful lot, and tongue shows have been studied to a certain extent. So when I did this analysis, and this was due to a colleague of mine who is here today, so definitely a shout out to Greg Murray as far as his Caveman Politics blog. He let me go ahead and write about this for his Caveman Politics. And what I did is I did analysis, and I found that there was an awful lot of this behavior. Now, from this point forward, I've been working with graduate students, including Alex Johnson on her master's thesis, to look at the vocalics of his behavior and the functional characteristics of his statements during this hearing and his initial Senate hearing to see if there are differences. And I've been working with Emily Stouffer, who manually coded all of Brett Kavanaugh's eye blinks during both of these hearings. And eye blinks are an incredible indicator of stress. So what I'd like you to do is consider the nonverbal behavior and consider how it can be used as a punctuation as far as what is going on internally and what sort of message Justice Kavanaugh is trying to convey.
Said confidently that she had one beer at the party. She does not say how she got to the house in question, or how she got home, or whose house it was. Fourth, I've submitted to this committee detailed calendars recording my activities in the summer of 1982. Why did I keep calendars? My dad started keeping detailed calendars of his life in 1978. He did so as both a calendar and a diary. Very organized guy, to put it mildly. Christmas time, we sit around and he regales us with old stories. Old milestones, old weddings, old events from his calendars. In ninth grade, in 1980, I started keeping calendars of my own. For me also, it's both a calendar and a diary. I've kept such calendars, diaries for the last 38 years. Mine are not as good as my dad's, some years. And when I was a kid,
Okay, so that's the entire video there. Now, a couple things I'd like to point out is that when you look at public figures, most of the time we're looking directly at the individual who's speaking. What I find is very edifying is to look at the individuals behind them to look at their behavior. So at the State of the Union addresses, I tend to focus on those individuals who are sitting behind the president as the comments are being made. And oftentimes it will show indicators that might tell us whether or not they will be able to cooperate. Another thing that I find, and this relates directly to C-SPAN and the incredible work that it does, but sadly, to my understanding, Robert, correct me if I'm wrong, C-SPAN cameras cannot get into the Supreme Court. Is this still correct?
That's correct. We only have audio.
Okay, so we have oyes, we have that, but we do not have video of perhaps the most elite of institutions in the United States. And that to me is, it's potentially, it's disturbing because this is a democracy for all of us. And certainly we can discuss this, but I do hope in the future, and this was the hope of my mentor, Jim Schubert, that we would be able to get into the Supreme Court beyond just listening to what the arguments were about. Yep. Okay. So next stage is that of looking at posture and body movement. Now, posture provides an awful lot of information, and certainly it's something that can be seen from longer distances by larger audiences. So it's focused not just on one's group, but also other groups. And it's a preferred approach to communicate social status related signals. So if you've got an extended posture, you see it in pride and hubris, and it's conveying power and status. Whereas if the posture gets contracted, oftentimes this is connected with embarrassment, with guilt, and with shame. And this indicates lower status. So this is something I find rather fascinating, especially with our political figures and how they might be standing on stage and then posturing up and getting larger at different moments. Now, the body movements, and this is where it gets, for me, it's fascinating. There's some really incredible research that's coming out. And I'll talk about Marcus Koppensteiner's work in a few moments here. But the movement of the arms is oftentimes used to punctuate the statements while they're being made. And it can be seen with either aggressive movements with vertical chops, or maybe more egalitarian open-handed movements, which are a little bit more horizontal. So when we look at this, and I'm going to show some video from a variety of different sources, one of the things that I have become very fascinated with, and I'm quite edified that Erica Rosenberg saw the same thing. So it says, maybe I'm on the right track if there's other people who focus on this, who see this. But shoulder shrugs are fascinating because we know if we do a shoulder shrug and we drop it, if we've got our palms open, it's a pretty darn good indicator that the statements that you're making, you're uncertain about, or you're just resigned to what's going on. But if it's unilateral, it shows up subtly, and it's probably happening outside of the consciousness. It's not a signal to others that you know that you're doing. It's like, I don't know. No, it shows up subtly, and it's probably indicating leakage of ambiguous or even misleading statements. So we're going to look at some videos here, which I find rather fascinating. And then after that, we're going to look at the work of Marcus Koppensteiner with the German politician. So if you don't understand what she's saying, focus on the tool that he has developed and he's published extensively with. Okay, so let's go ahead and get this started.
Seeking advice from foreign policy experts. They served in my dad's administration, my brother's administration. Of course, that's the case. But I'm my own man. But you
And
respond
maybe
more to
because you
this.
haven't paid any federal income tax for a lot of years.
I've said and done things I regret, and the words released today on this more than a decade-old video are one of them. Anyone who knows me knows these words don't reflect who I am. I said it, I was wrong, and I apologize. We've defended the borders of other nations while leaving our own borders wide open for anyone to cross and for drugs to pour in at a now unprecedented rate. I'm going to bring back millions of jobs. Protecting our workers also means reforming our system of legal immigration. And we must support the victims of crime. I have ordered the Department of Homeland Security to create an office to serve American victims. The office is called VOICE, Victims of Immigration Crime Engagement.
Ökostrom dämpft nämlich den Preisanstieg, derzeit um 0,9 Cent. Und jedes Solardach, jedes neu angeschlossene Windrad führt natürlich auch tendenziell dazu, dass der Strom preiswerter wird.
And many of the people.
Yeah. Okay, so I think I'm on time. So let's talk about the takeaway lessons. First thing is nonverbal behavior matters. It informs us of social relationships, communicates survival relevant signals, and it indicates social status and communicative intent. And a lot of the great research considering how visually focused we are as humans came from Indiana University with Betsy Grape and Eric Busey. And their book, Image by Politics, is the definitive text from 2009 that gives us an idea of how images, how visuals play a role in politics. Following from this, and this is something that makes C-SPAN so very important, is that the camera shots chosen matter. Our perspectives of nonverbal behavior is the camera's perspectives. So the work that I've done on this stems from the debates back in 2016 with Hillary Clinton and Donald Trump. And what we did is with Robert Wicks and Scott Edelman here at the University of Arkansas, psychologists and a political communication scholars, we put together a large scale study, field study, where we had students watch video that's either coming from C-SPAN 1 or C-SPAN 2. And what we found is the camera shot, whether it was side by side or whether it was a switch camera feed, influenced perceptions of the traits of the candidates. Now, work that has gone on since then by Eric Busey and Harrison Gong, as well as with Devon Shaw and his Twitter mining team at the University of Wisconsin-Madison, suggests that this nonverbal behavior matters exceptionally much so. So Eric was kind enough to go ahead and send me some videos, and he's done some really great work with some incredible teams. And you see the eye tracking and your, I think that's your left-hand corner, or my left-hand corner. And then we see body movements, we see continuous response measures, and we see work by Paul Bowles and his team over at Washington State University with the neurophysiology with the galvanic skin response. So there's a lot of incredible research that is being done that's using the new technologies that offer us the opportunity to fully unlock what is happening, what is being carried in the C-SPAN archives. So at this stage, I think we can go ahead and take a brief breather unless you guys want to continue on. Robert, do you want to see if there are any questions?
If you want to ask questions, you should send a chat, and Andrea will and Connie will read those out. But if there's no, we didn't announce that at the beginning, but we'll take the questions in the chat.
I apologize.
That's all right. There's something coming in.
Okay, how frequently can body language be misleading? Well, that's a very good question, because I think that those people who are best at misleading other people tell stories that are true for them, but they chose the stories in which to use the nonverbal behavior. I think that there are some things that you can look for within, the body movements themselves that indicate stress, not necessarily deception. Such things as if you touch your nose, if you're drinking a lot of water, these might indicate stressors that's going on. The less control you have over something, the more reliable it is. I hope that answers the question.
Okay, there's another question here. The shoulder shrugs are pretty fascinating. What are they revealing?
Well, I think let me go backwards. I apologize. It looks like, come on, there we go. Okay, so what I see is oftentimes it's discrepant behavior where there's a statement that's made. And with a lot of political figures, you see with one individual in particular, it occurred when the ex-president was reading off of a stated script. And so the viability, the truthfulness might have leaked out, and that there wasn't as much belief in the statement as might be the case. So I'm not saying that it's a true lie detector, but it is a hot point at which to look further and see what is going on.
I don't see any other questions at this time, so save up your questions and put them in the chat to everyone, and we'll just proceed.
Okay, sounds good. Okay, so the next step is to look at the facial action coding system. So here's the point at which I get to make faces at you, and I hope that you get to make faces at each other. I would ask, can we have individuals essentially show their videos to each other at this point? If this isn't the case, what I'll ask is, oh, there we go. Okay, excellent, excellent. So we've got some great people who are going to make faces at us. So let's talk about, first of all, the facial action coding system, an introduction to this. It was developed in 1976 out of previous systems by Paul Ekman, because he realized that a lot of the approaches previously were focusing on displays, not necessarily the muscular actions themselves. Now, originally, you looked at around 44 action units or descriptors in the face, 12 action units or descriptors with change in gaze direction and head orientation. There has been some movement in this. There has been some changing of terminology, but basically the muscles stay the same. And it's the same approach. Matter of fact, it's the same textbook from the year 2000. So it's pretty old right now. But materials, well, they work. With coding, it's from trace, which is the A level, to an E level, which is 5 points, which is maximum intensity. And it is used by a broad variety of coders in academic disciplines as well as business endeavors. Now, psychologists certainly use this. As far as political scientists, I only know of about 2 or 3 people who have gone through this. And to my understanding, I'm the only political scientist who currently is certified in the facial action coding system. Although there's a political communication scholar, Elena Spetieva, who I've been fortunate enough to work with, who is also certified in this. As of 2010, when I was certified, there's around 4,000 certified coders. It takes 100 hours worth of training and practice, and then you have to take an exam, a FACS examination, to move forward. But the thing is that as we've gone through this COVID pandemic, Erica Rosenberg has changed our approach from doing face-to-face, in-person, week-long classes to doing things online, which provides an incredible opportunity for anyone who is interested to work with her and receive training from her, whether it's in a workshop over the course of, I believe it's 7 or 8 weeks, in learning groups or in tutorials. She will do in-person workshops. I talked with her last week, but that needs to be set up by someone else beforehand. So I'll have more information at the end of this slide here, and I will share out the deck at the end of this. But this is a listing of the action units and the action descriptors from the previous edition of the book. And we're going to briefly go ahead and start with making faces at each other. So the first thing to consider is the eye patch. Now we're seeing different primates, and you notice that humans are the ones that have white sclera, which helps us see where the eyes are looking. It is the white blotches that you can see from a distance, and it tells about intent and the form of the eyes based upon the musculature around the eyes gives plenty of information, so much so that the theory of the mind, which is used to deal with Asperger's syndrome and people who are on the spectrum, they use the different sorts of eye configurations based upon the musculature. So let's go ahead and do an AU5, which is basically pulling up the inner lid so you can almost see the sclera above the iris there. Okay, can you see that, or is it too dark for y'all? There we go. The AU6 involves the musculature around the eyes, and there's a slight pulling down at the very edge of the eyebrow. Whereas the AU7 pulls the eyelid flat and even a little bit convex across the eye itself. The frontalis muscles are the ones that we're most aware of when we go ahead and raise our eyebrows up and down. But there's the medialis and the lateralis. The medialis pulls up on the inside and the lateralis is on the outside. So if I do this, this is a AU2 and it's on the right, it's left-hand side. So I'm doing a Spock right there. Now the corrugator we're aware of pulling the eyebrows together and down. Now the interesting thing is with this is oftentimes when we use EEG or we're looking at electrical measurements of this, people tend to assume that it's involved with anger, but it can be involved with many different sorts of facial behaviors as well. Next up, we're looking at muscles affecting the mouth patch and up and down movements. We have the nose wrinkle, which is the one that's most often associated with disgust because there's a wrinkling of the nose and a bleaching of right along the bridge of the nose of the skin and shortening, and at the same time, it inhibits air from coming in. The AU10 is an upper lip raise, and it's pulled essentially on the outside here, and it's a bending of the nasolabial furrow right in this area. And oftentimes there might be a little dip in the philtrum right in the middle of the mouth. The AU15, the depressor anguli oris, is something that I can't do very well. But what it does is it pulls the lip corners downwards. It's a lip corner depressor. That makes the face look longer. Now, the depressor labii inferioris pulls the lower lip down. And we see that if we can see the gums beneath the teeth at its most extreme level. And finally, the mentalis, or the chin raiser, is oftentimes used to control the mouth movements. And it's a pushing up of the lower lip. The buccinator is the AU14, is a dimpler, tightens the lip corners. And there might be a going movement up of the lip to a certain extent with a bulging of the nasolabial triangle right here, but it's not as strong. Whereas the risorius is a lip stretcher, which pulls the lips wide. Okay, and this broadens the face out. Finally, we have a whole variety of different movements of the orbicularis oris, which is such things as the AU18, which is the lip pucker. And one of the ways that Erica taught us is to think about saying fool versus AU22, which is lip funneler, which is flirt, which you see the inside of the lips. AU23 tightens the lip. And so it's not necessarily making it wider or longer, it's making the lips tighter and it pulls it inwards. Whereas the AU24 presses the lips together. The AU25, we have a lip parting, whereas AU26 for me is fascinating because it's a lip drop, which suggests that there's a natural relaxation that's going on, which signals, well, relaxation. And finally, you have the jaw stretch. So everyone, if you've yawned, and now you probably are because we're all very contagious, that's the AU27 in action. And finally, this is perhaps the most important muscle for sociality in humans. It's a zygomatic major or zygomaticus major. It's the lip corner puller. It pulls the lips at an angle and it forms the basis for the smile. And there are a whole variety of different smiles, which I will get to in a little bit here. So when we're looking at coding the face, what we want to do is, first of all, I think I should have put the last point first and then last, but being humble is the one thing that you are constantly reminded of, is you don't know it all and you can't automatically know what's going on because the face moves rather fast. And as we're in the video age, we can finally go through it frame by frame. But the first thing to do is do our initial impressions at a regular speed, write it down, and then do a frame by frame analysis, asking yourself, did I miss something? Looking at the lower face first, then looking at the upper face. And you go forwards and backwards from onset to offset and from offset to onset. And then you do a reference check to evaluate for subtle differences that might be the result of combinations of action units of the different movements within the face. And what this is oftentimes very, very time consuming. For myself, it might take 15 to 20 minutes once I am geared up to code 5 to 10 seconds of video. In other words, it's around 100-to-1 ratio. So for doing analysis, this is really tedious and time consuming, but there are the benefits that when you learn it from the bottom up, you know what's going on and it takes you to the next stage. And the next stage is using the technology that is out there. And that is what is incredibly fascinating as we move into our modern world. So right now, I'm just going to have this slide up here for you. I'm going to share this because I think that this is, if you're interested in this, getting the training for Erica Rosenberg is a great idea. And I'll say that it's now cheaper because you don't have to fly out to San Francisco or to Pittsburgh, as was my case. The fax manual, get this, it's around about $350. And Erica currently is reconfiguring it to make it a little bit more modern. She still has some of the classics, but she's doing a great job of trying to bring it all together in a more streamlined approach. Now, if you do train with Erica, it's going to be around about $1,000, $800 to $1,000. But it is very effective to prepare you to take the next step, which is to look at automatic coding, which is the next stage of my presentation. And this is what I'm most excited about because I get to shut up and listen from other people for a second here. So let's go ahead and get started with learning the basics, or the basics emotion model, basic emotion theory, which is basically, okay, that we have 6 to 7 different emotions: sadness, anger, happiness, fear, disgust, surprise, contempt. And this is great. This is a wonderful start. And this is something that was done initially by Paul Ekman. Well, it's obviously probably about 70 plus years ago. It's been a long time now. And it does help us understand some of the things that are shared across cultures. But as we can understand from our interactions with people, there's a lot more information encoded in the face. And so this is what I'm going to be doing currently with my political communication class. Starting next week is we have a unit looking at how facial displays cohere with the actual statements. And it means understanding, first of all, that our faces, the physiology, the physiognomy of our faces communicates information automatically. We're biased one way or the other. That's the first step. But then moving beyond that is saying, okay, what is the basic emotions model and how does it apply in politics? And this means understanding that there are, within political ethology, there are emotional displays in the context of rank to understand, such as if you're in a competitive situation, you're more likely to show anger and threat versus fear submission in response to that anger and threat when you're in competition. But if you're not competitive, if you want to be affiliative, this is where we show happiness and reassurance versus sadness and appeasement. But if you notice one problem here, the problem is that it's rarely the case, first of all, that we see these emotions as coded, as expected by the emotion facts. The second thing is that we focus mainly on negative emotions. And one of the great things about the research that I do is by looking at smiles, which is going to be our next stage, we're able to look at different sorts of positive emotions, which might mean such things as contentment, joy, interest, pride, pleasure, and awe. So bringing that in moves us from focusing solely on the negative aspects of being human and starting to look at some of the things that make us, well, feel pretty darn good, which is a great start. So that leads me to the componential or the component model of emotion appraisal, or the CPM. When I started doing frame by frame analysis, I noted that, well, first of all, smiles, they might occur as expected. It's the Swiss Army knife. We'll go into a greater detail later on. But when you consider the presence of muscle contractions, you're looking at the strength of the contraction and the timing of the contraction, there's so much more going on. And with the CPM, what you're seeing with the facial display is an event leading to evaluation or appraisal of relevance, implications, what the organism, the individual, will do to cope, and then finally considering the normative significance of it. Okay, let me let another person in. Okay. Now, the work that has been done by the people at University of Geneva, including a good colleague of mine who I've co-authored with, Mark Mayhew, has considered that there's a lot more going on than just the expression of emotion or the display of different behavior. We have a lot of things that's going on unconsciously. We have cognitive appraisal, obviously. We have physiological symptoms, motor expressions, and action tendencies that show up in the body. But then you have our conscious representation and regulation of our behavior, due in part to whether we have a high level of introspection and interoception, the ability to know our own body. And then finally, you have to have the ability to verbalize and communicate your emotional experience, which suggests that the models that we've been using, which essentially are self-reports, might not be as powerful as we need. And this is what leads us to the next step, which is teaching our students to move beyond the basics. I've been trying to figure out what is the very best way to communicate this when you have an incredible tool and you don't use it to its fullest. I thought about using a cell phone as a hammer. My sister, who is in the cell phone technology sector, she suggested it's like when you buy a smart television where you can get all the channels you watch and you only watch 2 channels, focusing on Wheel of Fortune. And so I think the thing is when we focus only on those basic emotions, we're missing a lot. We're missing an awful lot of power. And it starts with us both as instructors, teachers, professors, and as researchers to use this technology to its greatest extent, because there's so much going on with humans. And with that, I will let the, there we go, the iMotions team step in and tell about how I use some of the technology in the classroom, because they have helped me over the years with my teaching of the political communication class, but then talking about their technology. And they've got 10 minutes, so I'm just going to turn it over for this entire 10 minutes. So, Coy and Ashton.
Yes. Let me share my screen.
Excellent. First off, thanks, Patrick, for inviting us here today. Really happy to be here. Hi, everyone. I'm Ashton Terrian, one of our client solutions consultants here at iMotions, and joined by my colleague, Coy.
Hi, everyone. My name is Coy. I'm the technical client consultant here at iMotions. Prior to joining iMotions, I completed my PhD at Duke, focusing on computational neuroscience and decision-making.
So today we wanted to share more about iMotions and also give some concrete examples how schools have been able to use our software and the kind of research opportunities it's unlocked for them. And building off what Patrick shared, iMotions can be used as a teaching tool, and that's really just one part of the iMotions ecosystem. And so we support both academic and commercial clients. And as you can see, there's a really nice synergy between these. And empowering students to be part of that research process. So we have a lot of content that we've developed. So things like comprehensive pocket guides across all of the different biosensors that we work with. We have blog posts, webinars, and we even have a specific licensing model for student licenses, because students can read a lot of papers, but having that hands-on experience with these tools really gives them the opportunity to further their learning and can even open future career opportunities for them as well. And so taking a bit of a step back, Coy, if you don't mind going to the next slide, you might be wondering, so who is iMotions? We're a software company that specializes in biosensor-based research. And our platform that we offer integrates and synchronizes various pieces of hardware used to measure human behavior. So things like eye tracking, galvanic skin response, EEG, so stuff that Patrick has been talking about today, we can pull together those different signals and get a more complete picture of what's happening with people. And one piece of our offering is facial expression analysis, and that can be used in isolation, but it also can be used in combination with some of these other tools to drive deeper insights as well. You go to the next slide. Our team at iMotions has a lot of expertise, as I mentioned, working between both commercial and academic clients, and have the ability to partner with you and think through, what makes the most sense for the research that you're looking to conduct, or what makes the most sense for the department, and how we can help orient some of the tools we offer and really consult with you on how we can help further your research. And so with that, I'd like to pass it off to Coy to talk more about some of these concrete examples of how we've used facial expressions with some of our clients as well.
Awesome. So I get to do the fun part to talk about the science, given my background here. And Patrick, you mentioned Paul Bowes. It's funny, we actually do a lot of work with Paul as well on the communication side as part of our academic partnership. So it's always fun to see Paul come up in conversations, given how prominent he is with a lot of the biosensor research in the fields. So with respect to this being more of a political science conversation and forum, I just want to kind of highlight some of the work that other labs around the US and how they have utilized iMotions to better understand subconscious emotional responses. And in this case, from the participants that they bring in, especially during the election cycle that we just had. So for some of these labs like USF, Texas A&M, and even BU, our local university here in Boston, they were able to bring people in to then use iMotions to look at their subconscious emotional responses coming from skin conductance, heart rate, EEG, eye tracking, and most importantly, facial expression, especially when they're going through any of these Democratic debates or Republican debates. So it was really fun to see that even during COVID, some of these labs were able to set up a way to bring in people and doing this type of research. one of the things that I really like about the way that iMotions work with our partnership with a company called Affectiva is that you don't have to record the video and do it live in order to gain insights on facial expression data. So Patrick had reached out to us around last fall to help him create some course content material, looking at some of these videos here from the Democratic debates. And these were the closing statements from these candidates at that time. And what we're able to do is in iMotions, and, in addition to collecting the data live, you can actually pass in any videos that have been pre-recorded and run the algorithm, and in this case, Affectiva's algorithm, to better understand whether some of the action units, the facial expression action units that Patrick had mentioned, and on top of that, how are these action units combined together in the M facts or emotional facts kind of way to understand these 7 sort of basic emotions: anger, joy, sadness, etc. But as Patrick has mentioned, sometimes if you just use those type of coding, you can miss a lot, especially when you're talking about there are different types of smiles that he will actually go over with everyone here. And in this case, looking at the video closing from Amy Klobuchar. So the quote here that she just finished saying was that, first, I listen to the people and that's how I get things done. That is my focus. I have a track record of passing over 100 bills because I listened and acted. And I think that is important in a president. And she made this very faint smile, but in this case, it's an affiliative smile. She's trying to connect with the audience as she's making her closing remark. And something like this can be analyzed rather quickly with our software here, but you just run the algorithm on top of this video, and it can take about, let's say, 50 to 60% of the time of the duration of the video to run. And from there, you have the actual data to make insights upon, to synthesize together. So this can be really good learning material and a good tool to do analysis there. So with iMotions, you can do more than just facial expression. And this is where we excel, and we are proud of that. So the way that iMotions approach mixed methods research is that we synchronize all signals that you can potentially bring in, whether that's facial expression, eye tracking, heart rate, skin conductance. All of these signals are collected with time synchrony so that you can make event-related insights and judgment. So in this example, I have a colleague of mine, Q, and Patrick, I know you know Q here. She's watching a trailer of a horror movie, which she is not a big fan of this genre. But the coolest thing that we can see when hooking a participant up like this to understand the reaction is that you can see their facial reaction. So in this case, when the movie turns on, the trailer turns on, it's an abrupt image of the scary nun. You can see her fear reaction and surprise. But the other thing that it leads to is a cascade of responses, right? So you have that quick emotional response, but the cascade there leads to an increase in emotional arousal as measured by skin conductance. So in this case, think of it as sweaty hands or clammy hands, because she's just not into this, right? She's sitting inside a room all alone, watching some of this. And then from there, you'll see that she has anxiety-driven smile and lip pressing. And all of these moments are captured, in a very time synchronized manner for you to actually go back to either do a qualitative assessment on this or even do a quantitative assessment on this, either in our software because we are end-to-end, or outside of our software because we can export all of these data out raw for you to do your analysis. But given COVID, we know that oftentimes bringing people inside the lab at this point has been hard and has been very difficult. So our original model was always an in-lab solution. You can do testing with a desktop solution, or you can do testing, which is a simple laptop with the iMotion software on top of that. But since then, we have actually developed to bring iMotion's technology to the cloud, where you can also conduct this type of research to gain deeper insights above and beyond behavioral responses using our remote online solutions. And with this, you can also do very similar types of research you can in person, where you can use the webcam data to allow you to get insights on facial expression, as well as use webcam data to get insights on eye tracking. So we have developed our own algorithm to look at webcam-based eye tracking. And that allows us to better understand when someone's in front of a camera and looking at the screen, where are they focusing on, what are they seeing, and you can get that data in real time once it's been collected. And the other coolest part that I have been loving with this, as I have helped develop this platform out a bit, is our integration with survey engines out there that are very commonly used. So something like Qualtrics, Decipher, SurveyMonkey. So with this, we continue our tradition of being an end-to-end solutions if you wanted to, which means you can use iMotion exclusively, or we can be an integrative aspect of your research. So if you have an original workflow that you don't want to deviate from, but you just want to use iMotions for a small part of that, you can as well by integrating us into that workflow. If let's say you already use Qualtrics or you use SurveyMonkey prior to that. So with that, I just want to give you, the team here, a quick and kind of a teaser into a study that we had collected using our online platform. So in this case, it turned out to be a political science-esque type of study, where the study that we want to understand was, around the time of the election, and then, up to the beginning of this year, the U.S. political landscape is more divided than ever, right? So what we want to see is that, does political attitudes affect our emotional experiences to different stimuli, such as videos, images, and how do these attitudes manifest in differences in behavior, such as our facial expressions when we're watching videos or looking at images, or even what we pay attention to on these items. So with that in mind, I'm going to show you some of the results, the aggregate results that we got from the facial expression side.
I'm going to have to cut you off right here. We've got you 10 minutes. If we got people who are willing to stay around behind afterwards, we'll keep them all teased up. But we need to move forward with this. Thank you so much, Clay.
No problem.
Okay, so I am going to take back control of the screen now, I guess. Okay. Okay, so one of the great things about doing research as someone who looks at facial display behavior is looking at smiles and understanding that there are different types of smiles out there. We're social creatures, and understanding smiles, which is the Swiss Army knife, if you will, of social interactions, becomes so very important because they are omnipresent. And because we've Zoomed, we probably smile an awful lot now, and we smile at ourselves. In fact, I'm looking at myself, smiling at you. So in this feedback situation, understanding political behavior and understanding the research that underpins this has become important for me. Now, I've stated as a political ethologist, one of the approaches that I do is I take a bottom-up approach. I look at political behavior, and then from there, I move towards the coding of it within the context and try to understand what's going on. And I did a study a few years back with Eric Busey and Mark Mayhew, where we're looking at Republican candidates in 2012. And we found that there were distinct types of smiles that occurred. And you can see that they're posed, enjoyment, amusement, not as many enjoyment smiles, which I expected there would be more of, but there was amusement more often, which involved a jaw drop. And then you had controlled smiles, which is the lower lip pushing up, or there's some control of the smile to diminish the impact of the smile behavior. And finally, contempt smiles, which is a unilateral display. Now, fortunately, well, or unfortunately, depending on how you look at it, at the same time, there's some incredible work being done at the University of Wisconsin. And this is more theory-driven than anything, which was the idea that there were reward smiles, affiliative smiles, and dominant smiles that were driven by different social interactions. So reward smiles communicate positive experiences and intentions and are displayed to reward oneself and others. Affiliative smiles signal appeasement and are displayed to create and maintain social bonds. And so what I found is that the affiliative smiles and the posed smiles very close together, and the reward smiles and the amusement smiles likewise very close together. Now the dominant smile, which involves disgust, contempt, and anger with others and negotiate status, is also something I saw, but more in the contempt arena with political figures, which suggests that both the top down and the bottom up occurring at the same time or seeing much of the same things. Now, since this time, I've done some work with some colleagues in Great Britain to see if the same sort of behavior occurs and how individuals react to this. And I did fax coding of this, and we're looking at Boris Johnson here, his different smiles, but we looked at the 3 political figures that were involved at the time, whether it's Joe Swinson of the Liberal Party, Jeremy Corbyn of the Labour Party, or Boris Johnson of the Conservative Party. And we surveyed around 700 plus individuals, and I haven't run the data yet, but this is a great point to go ahead and turn you over to Noldus. And Shannon, oh gosh, I am going to mangle the last name, but Shannon and Peter Chen, and have them discuss what's going on, because my colleague, Carl Sr., uses Face Reader in his research. And I also have a colleague here at the University of Arkansas where we're going to be looking at research with this technology as well. So I will turn the floor over to Shannon Sanguinetti. Is that correct?
Yeah, very good, actually.
All right. Yay.
And you said it really well earlier also, so please don't sell yourself short.
Thank you so much.
So hi, everybody. Like Patrick said, we are from Noldus Information Technology, and we also have an automated facial expression analysis tool called Face Reader. Face Reader is a product of ours that's been around for about 10 years now, but as a company, if you're not so much in this behavioral coding and behavioral analysis field, you might not necessarily have heard of us. So Noldus as a company has been around for about 30 years now. We have a wide array of products that analyze both human and animal behavior. And our tools are multimodal as well. They can be integrated from, with specifically Face Reader, eye trackers, EEG, any kind of biosensors, as well as behavioral coding. So things that go beyond the face and beyond physiological tools. If you are a researcher that wants to specifically code things that you're seeing, you can do that as well, all in a synchronized manner. And so Noldus has 3 offices. One is here in Northern Virginia in the United States. The second one is in the Netherlands. That's actually our head office. That's where research and development goes on. And we are very open to the feedback that researchers give us. And we have a third office in China. All of our offices have dedicated support. So we have support across all time zones, and we are for researchers by researchers. And so the name of our company, Noldus, is actually the name of our CEO, and he started our first product 30 years ago. My research is specifically in how emotions can be more salient when stress is present. And so I worked in a little bit of a different model, but I'm really excited to talk to you guys about Face Reader today. About Face Reader, and I'm just going to request the screen. I thought it would be really helpful. And speaking about home offices, my camera's over here, but the screen that I need to show you is over here. So I'm sorry, I'm not going to be looking at you. But what I wanted to do is just show you guys the software. I'm sure you're curious about how some sort of technology can replace someone who's trained for over 100 hours. It can't necessarily replace, as we all know, there are different factors that come into play. Someone's life experience will ultimately change some things about their posture and some things. So it is really important to have an integration of both and not just have one replace just another. But Face Reader is really helpful. Like Patrick said, sometimes it can take hundreds of hours just to code video. And so this is really helpful in doing a little bit higher throughput, depending on the application that you're looking for. Face Reader can be used across a variety of applications. So you can kind of mix and match and pair it for what's required for what you need to do. The software, and what I wanted to do is actually start with an image where he's actually not looking directly at the camera. And so things that are required for software like this, 40 degrees of angle turn of the head towards the actual camera in question. And so Face Reader actually helps you, determine the quality of the image that you are using and whether or not this is going to be of high enough quality to collect data. And so what you'll see here is the first thing that the face reader is going to do is it's going to identify a face using the Viola-Jones algorithm, and that is specifically required to detect a face. It's an overall object recognition algorithm, but more specifically for faces. And so if I were to hit play on this video, as you'll see, it has no data here because the beginning of this video doesn't have a face in it. But the minute that we move to this portion, you can see the Viola-Davis algorithm is able to detect a face. And so now we have data being collected. The way the software actually works is it's going to create a mesh over the face that, first of all, is going to start with anchor points around the eyes, nose, mouth, and around certain points around the jaw as well. And the actual distance, remove that for a second, moved between each of these individual points is used to calculate whether or not the action units that Patrick were talking about. So I'm just going to jump to here. All those action units that Patrick was talking about, we can use here to then derive what is happening with what we would call a facial expression then. And so all these little micro expressions from trace, like he said, A all the way to E, max would be in this column here. You can see the onset and offset, and I'll just hit play here so that you can see the onset and offset, and this, the actual intensity of that micro expression, that muscle movement happening live. And so what we can do with Face Reader, and this is just the beginning of this video, is use these action units to then create what we have down here are custom expressions. And so this is one option for the software. The other option is to use the built-in, the 7 basic expressions that Patrick was talking about. So you can use this software for multiple different levels of comparison between if you are somebody who is more so wanting to just look at a website and whether or not, or a movie and whether or not somebody is enjoying that movie. There are more basic expressions here, but then they can be broken down even further. And so the first one I chose is to look at the ambiguous smile that we have here. And Patrick sent me 3 different videos that we'll talk about. We divided the upper and lower face. And so here in the lighter green, these are the action units compiled to show a genuine smile from the upper face, which would mean there's a lot of activation in these muscles. And then the darker color would be to see a genuine smile in the lower part of the face. So we separated them out. And this is on a scale from 0 to 0.3, but this can go all the way up to 1. I just made it more of a 0 to 0.3 scale so that you can see. And if you see certain portions here that peak, you can see his mouth is open. It's not necessarily a genuine smile, but we've moved out these to the top and the bottom of the face separately. Here, if you look at the lower face, there's very little expression going on here, but there's a lot more expression going on in the upper face. And as we go on, we can look at just these peaks to determine how much he's emoting with different action units. And so he basically has a small reward smile. Well, when he looks down, it's not very much, or I'm sorry, this is a relatively ambiguous video where he's not really emoting much. If we move on to his reward smile, there is a peak a little bit further on here where he's actually looking down, and this is the most rewarding smile that he's showing us in this video. Whereas there are a couple of other sections where he seems to be doing a little bit more here, but it's not there. Both of these lines aren't peaking at the same time to show us that this is a genuine reward smile all throughout. It peaks further towards the end here. And then the third is his affiliative smile. There's barely any motion going on here with the upper portion of his face. So there's a little bit of a smirk going on, but if you were to put this together, it's not a genuine smirk. And as we move on a little bit further in the video, you see that he's really just trying to appease the crowd so that he can, I guess, bridge that human comfort that Patrick was kind of talking about. So create a little bit of social interaction there. And so these are just a couple of things that we can show in the software. There are multiple different windows to toggle from here. We can also look at this window in terms of the expression. So these are all of the different expressions here going on over a line chart. It also shows different portions of the software, such as valence, so how happy or how positive on an affect scale or how negative on an affect scale is this person emoting at different portions of the video. And over the course of the video, what we can do is actually compile all of these different things together in order to get further insights, rather than just saying this person is happy or sad. If we couple this together with things like eye tracking, what we can see is that somebody might be looking at a specific section of the screen, but if their valence is relatively low, then they're actually disgusted by that portion of the screen, or they're not so happy by that portion of the screen. So these types of things with more technology can really bring in further insights into what we are looking at and how we genuinely feel about those things, but not by a human telling us, I like this video or I don't like this video, by a completely unobtrusive and unbiased tool that has no way to tell that this is specifically Boris Johnson. And so these tools can be really helpful long-term in understanding human emotion. So we just want to say thank you so much to Patrick for inviting us here. And we are very heavily used, like he was saying, in the research world, as well as many other applications like in flight simulators, a lot of consumption, food tests, and things like that. And if you guys would like to know more information about the algorithms or about how this tool is used, then feel free to let Patrick know and we can get you out some further information.
Okay, well, thank you so very much. I am very excited that we have two incredible firms here today. And I'm going to see about hopefully taking control again.
Yeah. I can just
There we go. And control, I have it to finish up and to open the floor to questions, which I believe they're probably going to be more to the firms than to me, which is exciting about this. Most of us are probably social scientists. If we're here, we're political scientists or whatnot. And we obviously are going to have a variety of questions that will be driven by the technology, especially as it gets used more and more. And if we address it now, then we can make better choices. So I want you guys to think about in the future some of the issues that will be raised. Privacy. We're on Zoom right now. There's videotape, and there could be real-time analysis of facial expression going on with our will or against our will. So that's something to consider. Facial expression analysis could also lead to more and better deep fakes. Robert and I were part of a panel this, was it last year? Over Zoom about deep fakes. And it's frightening stuff. It's frightening for all of us, especially if you have the ability to do a better job of mocking up politicians and looking at their behavioral repertoires. And what effect will this have on institutional trust of politicians if they are targeted? And finally, cyborgs. And I know you're going, oh, it's Patrick Stewart. Obviously, it's Locucius, a Borg kicking in right now. But truthfully, we're all cyborgs whenever we use new technologies in our daily life. A few years back, there's a Google Glass or the Google eyewear, which allowed for more information to be for an individual to use. The question, this is a question I brought up with both of the firms, I think we all need to deal with, is will there be a socioeconomic class divide between those having access to facial expression analysis technology and the training, and will it benefit them at the expense of those who cannot afford the technology? Now, I'm going to go ahead and reveal a little bit about myself. I'm a community college kid. I taught at community colleges. I taught at regional schools. I taught in the Delta, Arkansas State University. There's a alumni here as well that I'm proud of, very proud of. And I'll say that why I do facial display behavior is this, is that those in power expect to be observed. It's the province of the powerless to observe them. To be seen and not heard is what the powerless are supposed to do. But if you're able to derive better and more information, that gives power to those who are observing. This technology has the potential to give the powerless more power. And as a political scientist, and as someone who wants to see a better world, a more human world, I think this is one of the major ethical issues we need to address. So with that, I'd like to thank a variety of individuals, and I've talked about them previously, so it's there right now. But most of all, I want to turn this over to, as I say here in Arkansas, all y'all. It's not just y'all, it's all y'all to ask questions of me, but probably more likely the representatives for iMotions and NOLDIS. Shannon, Ashton, Coy, and Peter are incredible individuals, and I've had the distinct pleasure of working with them to set this up. So let's go ahead and get this started, if we will.
A question for NOLDIS. I'm just going to open. Does this NOLDIS software have the capability to zoom in on the video? We don't have the capability to zoom in on the video, but as long as the face can be seen in that frame, we can detect it with the same accuracy. We do prefer that head to be a little bit bigger, just because it makes a prettier picture, but we can still get the same information from a smaller image.
Okay.
Can I add another point to what Shannon says? Although there's no digital zoom to the video, but you can draw an area in the video. You can select, for example, a particular person's face to analyze it, especially for a video that has multiple people in it. But it's not a zoom, but you can select an area.
Okay. How effective is the software at examining older videos that are not as clear? It's to both of you.
For NOLDIS, it would depend on standard definition is completely fine. So I think it's going to depend on how old that video might be.
The older analog video, if you digitize them into MPEG-4, so it's about 640 by 480. So that's pretty much standard DVD video or analog video. You digitize those, then that will work just fine. Actually, the high definition video really doesn't add much of the data quality to it. As long as standard, that will be just fine.
Yeah, oftentimes on our end, we also recommend if you just want a video of 640 by 480, which is a resolution before sort of high def, are usually is fine. As long as you have a clear face. Just know that depending on how old this video is, if it's way too grainy or if there's a lot of pixelation in the faces, the models themselves will probably pick up that as noise when it's going through the images. So if you can somehow touch up the videos before feeding it through, that would be better to clear up some of the pixelations.
Okay. And are all these videos without audio? Is the audio matter at all?
No, unless you want to do sentiment analysis on the audio. Oftentimes, if you just want to do the sentiment analysis on the visuals, so this is the faces, you just need a stripped out a video without even sound. So you don't need sound for it to work. But it's always cool. I always love to do these in parallel to look at what you can pick up with the visuals and what you can pick up with the tonality of the speech and the voice, because there's a lot there that you can miss with just the facial expression algorithms.
Same thing goes for face reader. Audio is not required at all. Some people do like to use it in order to add custom in the software. There's something called event markers. And so you can actually mark different types of speech if you would like to, and then compare that to different portions in the software. So if that's something that you wanted, you could add that in.
Other questions? Any other questions we have here? It's been a very good discussion. It's, I think, really opens up to a lot of people the possibilities, particularly since I'm sitting on 260,000 hours worth of video, political candidates and presidents, and you just want to see, Patrick, you want to see Michael Dukakis answering that question years ago of what would he do if his wife was raped, and he said, and he gave a real nondescript answer, and you want to sort of see his face now and sort of see, and do that analysis of our Donald Trump or Hillary Clinton. There's so much to study.
Yeah, I think that's pretty awesome there. Michael Dukakis wasn't emotive enough. Now we've
Yes.
gone a little bit the other direction, not pointing fingers at any ex-president, but I do have a question for both firms. One of the things that I've been talking with Robert about is the need for C-SPAN, and if you've got two cameras, to have screen and screen or split screen. But currently we have switch camera feed. How is this addressed within your different technologies if you go from one camera feed to another camera feed?
That's a good question. So with respect to how we do facial expression analysis in iMotions, especially with Affectiva and Realize, the other vendor, is that it requires sort of a stable face on screen. So right now, if we're recording this video, you just spoke and then I spoke, there's going to be a switching of our faces. So oftentimes what I've done there in order to help clients get through those issues is just to run through using computer vision to actually identify when a screen has been flipped. And I would just then segment up that video and stitch together the relevant components. So I can stitch together your part of the video, feed that video in and analyze the facial expression. So some of this will require, depending on how you did the recording back, will require a little bit of elbow greasing outside of the platform like iMotions in order to get a set of stimulus for the analysis to run through. But if you do something like a Zoom where you have the grid and the grid is not changing, you can just identify the face that you want to analyze in that particular grid. As long as that's stable, the analysis will be just fine there. So this only occurs if you do that flipping back and forth with active speaker.
Mm-hmm.
Face reader works the same way.
There's a question here. What about glasses?
Yeah, glasses question is interesting, right? Because oftentimes what you will want for all of these algorithms are the landmarks to be around the eyes, the nose, and the mouth. So oftentimes around the eyes, if you have very thick rim glasses that block something like the eyebrows, then you're gonna have some issues there. But oftentimes if the glasses themselves kind of go around the eyebrows big enough, but it's clear and go through it, you'll be fine. But we find issues where the rims are too thick that then covers the eyebrow, because those are landmarks that are required, right, to extract features from that eyebrow region to make insights on those action units.
Okay, all right. Do I see any other questions for anyone? It's been a great discussion. And if you want to hang on and talk to any of the people individually, you can still do that. But we'll let everybody else go if there's no other questions. It's been a great discussion. It's a great opportunity. Patrick, I'm going to have to follow up with you to sort of see what we can do at Purdue University to get some people interested in this, because we need some faculty to take the lead, and then we'll be in touch with the companies to sort of see what the software can do for us. So it's a lot to be learned.